All of the work that Virts and Wilmore are doing on their spacewalk tomorrow is getting the station ready for new hardware, two international docking adapters called IDAs that will be installed on station docking ports so that future commercial vehicles can dock to the space station. The adapters were manufactured at a Boeing facility near Johnson Space Center, and recently my colleague Kyle Herring visited the facility to talk about the hardware with Sean Kelly, NASA's senior project manager for the relocation and international docking adapters. And Kyle asked Sean why we need these adapters.
So the international docking adapter is actually the first implementation of our international docking system standard. We've developed that over the past few years with all our international partners. So it's really the first standard that we have in the spaceflight business. And as such, we wanted to lead the way. And NASA established an effort to develop the international docking adapter. We try to put the emphasis on international because although it's in the critical path for commercial crew, this is also a key element for what we plan for other international partners to come to the space station and start utilizing it in the future.
Well, we know we've got some critical spacewalks that have to be done ahead of the arrival of the first IDA. In your title is the word relocation. Of course, there's a lot that has to happen associated with the spacewalks and, of course, relocation. Talk about the relocation phase that has to happen, basically the setup before you actually get to the point of delivering the IDA.
So we're establishing two international docking ports. One is on Node 2 forward, the other one is on Node 2 zenith. And that's to allow for the traffic models that we have for the space station, multiple visiting vehicles, and they'll even support two visiting vehicles at the same time. Commercial crew, commercial cargo, international partners, we're in a good position to support the various traffic models that we have planned. As part of that, though, we have to also allow for berthing. And today we have two berthing ports. We want to maintain that capability to have two berthing ports on the space station. So we want to, in order to do that, we have to move some elements around. So one of the elements we've got to move is the existing PMA, pressurized mating adapter. We had two of those to support space shuttle. We'll have two of those as the basis on which to put the international docking adapters. But we have to move one of the PMAs, PMA 3. We also have to move the PMM, pressurized multipurpose module, from its current location in order to get the clearances and approach corridors that we want for the visiting vehicles. This entails a tremendous amount of relocation. This is the largest project we've done, certainly since the end of the shuttle program. It spans 3 increments, 5 EVAs, about 800 hours of internal crew time to configure the station. So it's a very exciting project to do, and we're really setting the gateway for the future for commercial crew and other international partners to come to the space station.
One of the reasons that we're here actually is we are in Boeing's facility down the road, the Houston Product Support Center. Boeing obviously a contractor to build these, but it's a multi-contractor partnership because not only is Boeing building this, but it's going to be launched on a SpaceX Falcon 9 aboard a Dragon in the future. The first IDA is already at the Kennedy Space Center, the first flight unit. This one is the flight unit number 2. You've been part of this for quite a while. Talk about that partnership between not only NASA and Boeing, but also the SpaceX component of this to get this project completed.
So this has been the International Docking Adapter project has been involved numerous contractors. We've had our prime contractor, Boeing, as the lead integration contractor for it, but they've used numerous contractors across the United States. I believe at last count we were drawing products from 25 or 28 states, so it really is a large collaborative effort. We also get major components, the primary structure from Russia, from Energia, and that has been very beneficial to the schedule and also to the international collaboration aspect of the international docking adapter. And of course we're flying it on SpaceX. So taking something new, flying it on from a Boeing prime contractor, international components on it, multiple components from across the United States and flying it in a commercial cargo vehicle to the space station. It's all been very rewarding and very interesting, and really brought in a lot of elements from across the agency to try and make this happen.
As I mentioned, we're in the HPSC, and what we're standing next to is the flight unit number 2. Where we're standing, you can see the size comparison, but talk us through just a little bit about this unit and how big it is, and size-wise and weight-wise that's being delivered to the station.
So this is International Docking Adapter number 2. This is serial number 2. The first unit's down at Kennedy Space Center. We will fly this up on a Dragon. This will go up on SpaceX 9 is the current schedule for that. And as you can see, it has EVA handrails all around it so that it can aid the installation for the crew. We also mount it in the trunk for Dragon by trunnion pins. So we have these trunnion pins, and that allows us to have a very secure mount. The IDA actually will hang suspended under Dragon as it's going uphill, and then it'll be extracted from the trunk. It weighs about 1,150 pounds. As you can see, it's roughly 30 inches from base to top. On the very bottom, it has a sealing surface, and that's what will go onto the PMA. It has guide pedals that allow it to be accurately installed. We're going to have robotic extraction from the Dragon trunk, and that the SPITM will bring the IDA to about 2 feet 10 inches within the PMA. And then the crew will reach out, they'll grab it, they'll put some tether straps on it, then they'll bring that down manually. It'll be released by the robotics. It'll be manually brought down by the crew onto the PMA, at which point it'll be closed, and then we'll use some of these connectors on this panel, and some internal crew members will flip some switches, drive some hook motors, and then it'll be fully installed onto the PMA for permanent use.
The crew that's actually going to do the manual part of this installation is Scott Kelly, obviously, is one of those crew members going up for a year, and as recently as probably January, even maybe earlier this month, he was looking at these down at the Cape and looking at what he's going to do on orbit based on what you just said, right?
So we've had Scott Kelly out here to look at the hardware, not only IDA 1 but also IDA 2. He's seen it during the build-up process, so he gets to see some of the internal workings of it. We've made sure that all the crew members that are potential candidates for installing it have had the opportunity to see it and get familiar with the hardware. This is 1,150 pounds, so it's not trivial. Even though it's weightless in orbit, it's still a big heavy object for them to move around from a mass point of view in orbit. So we wanted to make sure they were fully familiar with it before they flew. And I believe Scott Kelly's going to have the opportunity to install both IDA 1 and IDA 2 on orbit.
We're in the Space Vehicle Mock-Up Facility, the location for the mock-ups that you see associated with the International Docking Adapter. Sean and I are here for Sean to give us a little demonstration of what actually will happen on orbit and what these mock-ups are used for in terms of training to get crews ready to head to orbit. So Sean, give us a little demo here of what we're looking at and the importance of it to the International Docking
Sure.
Adapter and the future of the commercial crew and other visiting vehicles.
Sure. So what we have here is the International Docking Adapter. As you saw in the previous video, it has 3 pedals. It's also mounted on the pressurized mating adapter, which is the back portion of this mock-up. The crew uses this mock-up for ingress and egress training, as well as familiarization training for it. As you can see, it's not highly detailed, but it's an adequate level of detail for all the training operations that they have in the facility. What we have behind me is the active docking system. This represents what would be on the front of the visiting vehicle, a commercial crew vehicle or other international partner vehicle. This also has 3 pedals on it, as well as mechanical latches. These latches will strike over to the IDA on their striker plates, and that's how the attachment of the visiting vehicle to the IDA will happen. That normally happens with a soft capture system extended, and then that soft capture system retracts, thereby making the 2 halves of the docking system go together and mate. That creates a pressurized seal and a structural seal between the 2 of them.
The crew training aspect of this, we They obviously work with the actual flight hardware, but they also have to interface with this training equipment and describe that for us. It's really more of a ingress and egress type function for the crew members rather than the functionality of the actual system, right?
Correct. So when a visiting vehicle comes, there's a lot of reconfiguration you have to do on the space station. You've got power and data exchange that happens automatically as part of the docking adapter, but there's also air exchange that has to happen. They have to put in some duct work, and that's to allow air exchange between the visiting vehicle and the space station once it's docked. And so they have to do that configuration, as well as there's a existing target that they use for docking on the front of the hatch. And once that hatch is open, they have to remove that docking target from the hatch so they can egress into the vehicle smoothly.
Well, Sean, we really do appreciate you taking time out to show us this hardware that's headed for the International Space Station, the International Docking Adapter, both of them obviously getting ready to fly, and we really appreciate you taking the time out to show us the hardware today.
Thank you for the opportunity.